Go. Okay. We'll start from current slide. And I think we had finished this slide last time. Okay. And we were getting ready to start when. All right. Now, where are we? Okay. Shaping Our Service, Chapter 20. We don't have much more to go. I think maybe just a few pages. So fairly shortly we'll be through with Chapter 20. We'll jump on over and start Chapter 23, which is the weather and climate, which goes to Melva's question. So we'll get started on that today, and probably, I'm guessing that we probably won't quite finish 23 today, so we'll be doing that on Thursday, okay? Now, at the last 2 hours today, we're going to have the lab. It's not really pertaining to this, but it's related to all these chapters are sort of related together. So we'll continue chapter 20, start 23, and then when 3:45 comes, we'll start the lab. The lab today is, I think, a relatively short lab. There's pieces of it, and different ones of you will be working on different pieces at different times, but you can work together. So I think it'll go pretty smoothly. It usually does. All right. So then on Thursday, just guessing, we'll finish chapter 23. There won't be time. Oh, wait, yeah. And at the end, we'll have the test on chapter 20. That'll be Thursday, the last 30 minutes. And more than likely finish 23, so I'm guessing we'll start 24 then. Next week, okay, Tuesday is when we go to the planetarium. Long time waiting for that one. So we'll go to the planetarium. We'll meet here at 1:15 and leave just as soon as we can. So if any of you, it's more convenient for you to go straight to Sanford rather than coming here, you can do so. Just try to be there before 2 o'clock. We're going to try to make it before 2 here. Now, and we still have time to talk about this on Thursday too. Do any of you need transportation, or would you rather drive on your own? I highly recommend you pool it together as much as possible, just because Sanford in the middle of the day, fall term, parking's not going to be easy there. I mean, there's parking, yes.
Are we coming back here after we leave?
I'm coming back here, and I'll continue with recording or whatever the class. If whoever can be here should be, okay. But yeah, I haven't talked with him since we first set it up, and so he didn't at that time have an idea exactly what he was going to do with us. But usually he has us for between 1 and 2 hours. Okay. Sam's here. What's that? Sam here. Okay, USA. Okay. So I'm guessing we'll be through between 3 and 4. That gives us plenty of time to come back here. Say even if it's 4 o'clock, we'll get here at 4:45, and we still have an hour to go. So yeah, we'll continue to have class. Now, if any of you, if it's inconvenient for you to come back, whatever we do in class, I'll be recording. It's just hard to see ahead what we will be doing at that time. But since we may be pooling together to go, then cars will be coming back here because, and if I take people, I'll be bringing those people back. So we will be coming back. Some of us will anyway. It's up to you whether you come back or not. That's completely up to you. Yes.
How big is your car?
I'm sorry?
How big is your car? How many people?
Oh, I have a RAV4 SUV. It's not a big SUV, it's a small one. And I can easily have take 3 students. If you want to try to do 4 in the back seat, we can do 3 in the back seat, then it would be 4 students. But yeah, there's a console in the middle, so okay, it would be either 3 or 4 students. Cece's here. If I can find you here, there you are. Okay. So now the other option is I can see if I can arrange to get a van, but I won't be able to get everybody in the van. But I will. I think I can carry 11 students. I think it's a 15-seat van, but they say the insurance won't cover more than 12. So, and the driver's one of them. That's me. So 11 students plus me. We can do that if I can get it. I have time to look into it now. So but I need to look into it now if we're going to do it. So is that something that y'all want or not? And that way I'll be certain to be coming back here because, I'll be I have to drive back here.
I would probably drive.
What's that?
I would be more comfortable driving myself.
Okay.
If that's okay.
Okay. Would you be coming back to campus here or not?
No, I do want to go.
Would you be coming back to campus here?
Yeah, of course.
Well, no, I mean, it's up to you. But I was going to say, if you're more comfortable driving, can you take somebody if you're coming back here? If not, you don't have to take them home. Okay. So what you think? Yes?
I'll come in the bus.
Second?
I'll come in the bus.
Okay. So you'd rather I try to get the van? Okay. It's not the big bus. It's just a van. Okay. All right. Well, then I will see if I can arrange to get that for next Tuesday. And it's going to be a little on the tight side. I think I can do it. I'll have to leave right at 12:15 because I have a class that goes at 12:15. Rush over there, get the van, and be back here by 1:15. But I think it's doable. Might be a few minutes late, but I'll have to let him know we may be a little after to get it there. So we'll meet anyone else wants to ride in the van. I mean, if we do a van. Okay. Okay, how many total? If it's just going to be 3 students. Oh, okay. If it's just going to be 3 students.
You going to feed us on the way?
Okay. So is it more?
Play it by ear. I'll be on campus anyway.
Right. So if it's 3, I can take you in my vehicle. If it's more than 3, I'll get the van. So how many want to ride with me? There was 1, 2, 3, 4. Okay. Okay. Let's talk about it again on Thursday. The one problem, it's not a huge issue, is I would be able to work everything out on Friday, except I've got an infusion on Friday. I'm not going to be on campus at all on Friday. So I've got to work it all out beforehand, but I think it's doable. Yeah, we meet Thursday, but see, I have so few office hours. That's my biggest chunk of office hours is Friday. It's wiped out this week. So, but I'll see what we can do. I'll make calls and tentatively arrange it, and then when I find out Thursday, I'll call her back and say yes, we need it, and I'll arrange to pick it up right at noon. Okay. You mean right at 1-ish? No, noonish. Okay. All right. So let's review for those who just came in. We're finishing up chapter 20 today. We'll start chapter 23 today. That's weather and climate. Okay? At 3:45, we'll stop wherever we are in weather and climate and do the lab from this. Now, I turned it in last night to be copied. And when I came in this morning, she wasn't here yet. So she wasn't here when I left, and she wasn't here when no, actually she was here when I left, but it didn't get copied. And she wasn't here this morning. Hopefully it's been copied now, but if not, I'll have to run down and copy it. So we'll do the lab. Then on Thursday, we'll finish chapter 23. And then at the end of that time, we'll have the test on chapter 20. So that will be on Thursday. And in between that, the lab for 23 is the other trip. So I'll start making arrangements for that. Melva's question, it may actually be on Thursday. So we may have 2 back-to-back field trips in the same week. But but I'll check into that as well. And then, so the odds are we may actually on Thursday, if we finish 23, we may actually start 24. And then we'll be in labs and stuff like this. So it could be that coming back from the lab planetarium, we could have a test here at the end. But if you can't make it back, you can make up the test anytime you want. So it's a little sketchy here at the end because we've got so many pieces moving around. But at least for today, 20, move on to 23, lab, the last lab in the geology, earth science part. And then Thursday, we'll probably finish 23 and may even start 24, and we'll have the test for chapter 20. Okay? And then we'll talk about what to do about the rest of it. I think I've got everybody who came in. Okay. Yes. Was there a question? Oh.
He wants to ride in the van.
What's that?
He wants to
Ride in the van also? Okay. So it sounds like we got enough to get the van. All right. So we'll... Here's a little, it's not a problem, it's just an occurrence, okay?
What?
The rest of the office hours I have this week, you know, on Tuesday and Thursday, I only have my lunch hour, okay? On Monday and Wednesday, I usually have 3:15 to 5:45. No, 5:15, sorry about that. Except now the math team's been meeting for most of that time, but then tomorrow, in addition to math team, I've got to cover a test for Dr. Thomas. So it's sort of like, and then Friday my office hours are eaten up because I'll be on the having an infusion. So we'll figure something out.
How many students did you end up with on your math team?
What's that?
How many students did you end up with on your math team?
So far, I've only had one show up for one practice. Okay, they have many more on the math team, but they meet on the Birmingham campus. And you're trying to get recruited. Is that what it was?
I did.
Oh, you can. I didn't know you were experienced. Okay. Okay. If no other questions, then let's pick up where we left off. We've been talking about erosion. That was the last half of the chapter almost. The biggest eroder is water. Okay? Now, another big eroder, but it's very slow, and you don't see the results for a long time. Well, not that. We haven't gotten there yet. Ice. Glaciers. Okay? That does erosion, but it takes a long time before you see the result of it. Okay? Now yes.
Isn't it also true, I mean, I know water is the biggest erosion, but as soon as the glacier starts melting and it's around rock, wouldn't it start cutting into the rock?
Yeah, I mean, it's doing that right now, but you don't see the result of that until it backs up, melts and gets
How
up.
do they look at that information? Like, gather that information, like...
Well, they look at what happened in previous, like the ice ages. They could tell how far the glaciers came, and they came way further than what they are now. So you look and see what they left behind. So figure the ones that are happening now are doing the same thing those did before. Kind of our principle of uniformity, right? What the present is the key to the past. Okay. Now remember, we also had other forms of soil movement just by gravity. Soil creep, and also landslides, mudslides, avalanches, those kinds of things. But now we get to wind. Okay? Winds can blow very strongly, but they have very little mass. Kinetic energy is 1/2 mass times velocity squared. So a large velocity will have a fair amount of energy, but with very low mass, you have a lot less, so the wind is considerably less efficient than either water or ice. Ice has a lot of mass, especially a glacier, really deep glacier, and but its velocity is pretty slow. Okay, very slow. Water can move either slowly or rapidly, but it has more mass than wind. Okay. So let's look at wind. Two major processes. Now again, remember when I talked about erosion before, I gave you a couple of concepts. The book sort of talked about them, but just a little bit. Water erodes by two processes. First, it detaches and then it transports. Okay? A big old heavy water droplet hits the surface of the soil and breaks the soil apart and splatters it. That detaches it from the rest of the soil structure, and then the water, moving water, transports it away. So those are the two areas. Water erosion. The same two type things happen with wind. The first is called abrasion, which is sort of your detachment. Now, if the wind's strong enough and it's picked up little particles of sand and hitting a rock or something like that, we call that natural sandblasting. Okay? Now, I don't know, I wasn't down there. I'm glad I wasn't down there. But I bet you Puerto Rico had some natural sandblasting going on with that hurricane. Those really high-powered winds slammed into the island. A lot of times, this is a major, but it does happen. Now, this produces what they call the ventifacts, these sort of interesting shapes that you get. Venta means wind, and these are the artifacts left over from the wind. The shape depends on the prevailing winds, and that's what this slide shows. If the prevailing wind, usually in our area, is from the west, then if you have a mound of rock here, and the wind is always banging on it from the west and carrying things along, that's where it's basically carrying it down. So in time, this part has been worn off. And when I say in time, it may be a long time, okay? But this part is on the lee side, and it has very little of this abrasion going on. So that portion of rock, see, it was fairly symmetric before, but now you see this ventifact, the fact that you have a slow sloping side there, okay? But very little erosion there. Now, if you had a persistent shift in the wind direction, then you could start eating away on this side. That usually doesn't happen, not for long periods of time. Now, they do show, and it's a little bizarre, how they show the wind banging off it here. This would be typically if the wind picked up a piece of gravel or something and threw it onto there, that would then abrade it even worse. I guess that's why they have that down there. I can't think of any other reason. But the shape depends on the prevailing winds. So that's the detachment, the abrasion, natural sandblasting. The deflation is when the loose material is picked up and carried away by the wind. That's the transport. It's just with wind, we call it abrasion and deflation. In water, we usually call it detachment and transport. Same type principles there. Now, there have been a few times in our history, one particular one, when we had a lot of wind erosion. Does anyone remember what that time period was called? Second?
There's a time period?
Yeah, that event in history. It was called the Dust Bowl.
Oh.
It used to be a football game, but no, I'm sorry. Okay. When was Grapes of Wrath? Yeah, that was Steinbeck's book was about that time period. I think it was the. Say again? That's where it hit the worst. Yeah. 35. I'm guessing around the 30s. Is that what it was? 35. Someone just look it up. Yeah. Okay. I was just going to say the 20s or 30s, so 35 is better. Okay? Now, let's think about what happened then. Okay, let's think several things about you said the Midwest. I'm going to make it a little more, I don't know if this is better or worse, the Great Plains. Okay? The Great Plains are called the Great Plains because they're wide open expanses of land with very few trees. Here, even in town, we have plenty of trees, okay? So we're not going to be suffering a whole lot. Chelsea's here. Okay. And Fred's here. Turned out being fairly good attendance. We're missing Trey, Tiara, Ashlyn, and Kedrick. Okay? So we were just talking about wind erosion, and one of the biggest events of that we've had in our country's history has been the Dust Bowl. The Dust Bowl occurred, I'm going to use the term Great Plains, was the primary source of it.
Southern Great Plains.
Huh?
Southern Great Plains.
Southern Great Plains, okay. That would be Kansas, Oklahoma, that kind of area. Second?
Mexico.
New Mexico. Okay, I didn't know if it went down that far. Okay, now, here was the deal. Now, I don't even think this part pertains to New Mexico, but it parts of it. What had happened was we did our western expansion. You know, the East Coast was settled and people were moving west. Go west, young man, and grow up with the land, you know, and that kind of stuff. So there was a lot of movement to the west, and people came upon this wide open area, grasses like crazy, and they said, boy, this looks like pretty good soil. Okay? Now, the sort of unfortunate thing for the earth, not too unfortunate for them at the time, was that happened to be a time with unusually high rainfall, okay, in the Great Plains. So the people came along and said, look at this great soil, the great grass is growing. We can dig up this grass and plant us corn and soybeans and, you know, all sorts of good crops and make us a bundle of money here, okay? And actually, especially since they didn't have many trees in the area, they actually built their houses with sod. They called them soddies. In fact, there's still soddies in Nebraska. I stayed at a friend's house. Her mom lived in a soddy, okay? Now, it had a sheetrock or something put on the inside and a veneer put on the outside, so you didn't see the sod. But when you looked at the windowsills, they were that deep, okay, because that was sod. And what they do, they would just take up chunks, almost blocks of sod, and just stack it, you know. And it was great insulation, and they can have some pretty cold winters out there. And it was also, you know, cheap. I mean, they had to get rid of all that grass anyway. The topsoil went down for feet, so it didn't hurt them much there. So they built their houses with the sod. They took all those roots, those intricate root systems of those prairie grasses. They had to break through those anyway to cultivate. So it was just a win-win situation, they thought.
But doesn't they have to water it, keep it moist or something?
Okay, that was what I said. That was the time that was usually high rainfall. So they weren't having to. Today they do. They irrigate like crazy and drop the water table like crazy. It's not really all that sustainable, I don't think. I haven't studied theirs, but I know it's down in southern plains like West Texas. They actually have land subsiding because they pumped all the water out from underneath it, which is not a good thing at all. But they did this, and then came, and that probably lasted for several decades, going great guns, until the normal weather patterns came back, which were much drier. And now their crops failed. And now you had exposed soil that you used to have all this tough prairie grass with all that great root system, not there anymore. And the winds came whipping down the plains, and oh,
Sounds like a song.
okay, yes, it was.
Ready for
Okay,
you to sing.
yeah, you don't want that. Okay, believe me. Okay, and here came the wind, the unprotected soil, and there goes the soil. That was the Dust Bowl. Now they still have things like this in certain parts of the world. Any of you happen to have been in either Desert Storm or Desert Shield, or none of you? Did you know someone there? No one? Out there, they have dust storms capitalized. I mean, huge things. In fact, the equipment that is just, because they're desert areas, and the wind comes whipping down those plains, and you have just, it's awful, okay? And destroys equipment, you know. Dust gets into every moving part, you know, and it's pretty bad. Well, the same thing happened here, but it was good, rich farmland that was blowing away. And these wind-blown deposits, they form dunes, like you see at the beaches, where the wind blows the combination of the water bringing it up and the wind blowing it into dunes. These are low mounds or ridges of sand or other sediment. But the other term is luss. L is pronounced like it's L-U-S-S, luss. Okay? That's how it's pronounced. Fine dust, which means it's probably silt-sized. Silt, if you remember, was what the glaciers left behind. It ground that soil up. Yeah.
Wasn't it like 0 in the moss?
Say this again.
Wasn't it like at 0 at the moss measurement, moss weight, whatever it was called in the
Mohs scale? That was a hardness scale. Okay? But glaciers could grind down even some of the hardest rock, maybe not diamond, maybe not too much quartz, but when they did, you had a lot of silt left over, and that's what those Great Plains have a lot of. That's why there were such good, rich, fertile soils, but now they exposed them, and that luss, the fine dust, deposited over a large area. During the Dust Bowl, that was picked up in Kansas, probably Nebraska, New Mexico, those areas there, and carried, the wind was prevailing westerlies coming from the west. Some of that luss was deposited as far east as Philadelphia and cities in the East Coast. Now, certainly you start running into trees and stuff, and more of it gets knocked out of the air, but that is wind deposits luss. Fine dust deposited over a large area that was picked up from wind erosion. Not a pretty sight at all. You lost topsoil, never to be retrieved again, and then it was deposited elsewhere. That's wind erosion.
So what was the big fix? How did they fix it?
Say this again.
How did they fix it?
Fix it?
Yeah, still less.
No, they tend to do a lot better job of soil conservation now. In the areas where they do intensive agriculture, as Melvin pointed out, they irrigate. So therefore, they don't have exposed soil like they did. Back when they were just dry land farming and they didn't get enough rain, there were. Second? Irrigate. Is that what you meant? Yeah. They irrigate. Another thing they do, it's sort of like contour farming, except you are not doing it with the slopes, which is really what our lab's going to talk about today, but doing it with wind gradients. You plant your rows this way rather than this way, so the plants themselves prevent the wind from picking it up and taking it off. So there's several things they do like that. Actually, when Karen and I were driving through parts there, it's not so much wind, but it has to do with the wind. They have snow screens, you might say. They have barriers to keep the snow from being blown over the roads. Otherwise, the roads would become impassable. And that's not really erosion, but it's the same thing, wind blowing the soil. So they have these, they're just great big old structures that are there just to catch the snow, you know. And those kinds of things would also cut down on the wind erosion as well. All right. That was the one page they had on wind erosion. I hope I didn't overdo it. All right. Before we move into development of landscapes, science and society, we talked about this a little bit way back. In fact, the first of the chapter, acid rain, and that's what the blurb, it takes up about 3/4 of a page on page 518 in my text, gives you some pretty interesting things about it and questions to discuss. And by the way, folks, papers, uno is all I've gotten from this class. One, okay? Oh yeah, maybe a few more have come in today. Yeah. Okay. And this is a mini term, remember? You only have a few weeks left, okay? Please don't forget your paper. Yeah.
When is it due? When's the end of the class?
It's the last day of class, which is, oh boy. Last day of class will be a Tuesday, I think the second Tuesday in October, I believe. And then the final exam is on that Thursday. I don't have the date right here in my mind, but so it's not that far away. This week's the last week in September. We have this week, next week, and then Tuesday of the following week, and then we have finals then. So we're getting, as they say in the farm, on the short rows now.
I've already started working on it.
All right, good deal.
You
But
said no more than a page, right?
what's that? 1 to 2 pages. Yeah, that's what I asked you to shoot for. Acid rain would be a potential paper topic. Now remember, this little blurb can't be your source. You got to get outside the book to get your source. But some of the questions here might be of interest to you. Let's take a look at a few of the things in their table there. One of the strongest acids out there is hydrochloric acid. Okay? It has a pH awfully close to 0. This is 4% hydrochloric acid. Guess what? You have some of this in your body. In your stomach. Your stomach is an amazing organ because just the coating, the lining of your stomach has to be strong enough to withstand all that acid. And that's what breaks down your food. Anything you eat is going to be broken down in your stomach, and it's broken down by acids. Very strong acids.
So the lower the pH is,
The stronger the acid. Exactly. Okay? Now, I don't know if any of you have ever heard of acid reflux. People who have had it will tell you how strong that acid is because it can eat up your esophagus because your esophagus is pretty strong too. It can't handle that. If that coating on the walls of your stomach gets deteriorated, then what do you form? Ulcers. Exactly. People who have them will tell you how strong the acid is in your stomach. It is painful, okay, because of that. So your stomach acid is partly hydrochloric acid, near 0 pH. Oh, I'm sorry. Pure hydrochloric acid, 0. Your gastric stomach solution is between 1.6 and 1.8. Just about the second strongest, okay? Lemon juice, pretty acid, wouldn't you say? 2.2 to 2.4. That much higher than your stomach acid. So your stomach acid is much more acidic than lemon juice. Vinegar, 2.4 to 3.4, depending on how strong. Carbonated soft drinks, 2 to 4. Never realized it. That's one reason they put so much sugar in them. If they didn't, it would be so bitter, you wouldn't drink it, this stuff. So that's why they're so strong in sugar. Grapefruit, 3 to 3.2. Oranges 3.2 to 3.6. Those are all pretty acidy things, right? Acid rain 4 to 5.5. Pretty strong acid. Not nearly as strong as those other things, but rather strong. Tomatoes 4.2 to 4.4. Potatoes, not nearly so acid, but 5.7 to 5.8. Natural rainwater, not acid rain, but natural rainwater, 5.6 to 6.2. Still slightly acid.
Why
But
would
it's-
it have more than acid rain? Regular.
No. Okay. The lower the pH, the more the acid.
Oh,
Yeah.
okay,
Right.
okay.
Okay. It's the minus log of it. Yeah. So okay. But acid rain is rain that you had not just naturally occurring things, but you have sulfur dioxides and all these other things from pollution that made it acid. Yeah.
Do you know that oranges and milk, they have high percentages of acid? They're so good for you because milk has calcium and orange has vitamin C, right?
Right. Yeah. I mean, they're not bad foods. They're good for you, but just beware, they are still fairly acid.
Milk is a basic.
Yeah, no, milk is not quite a base, but it's a very, very, very weak acid. 6.3 to 6.7. Pure water is neutral, and that's 7. Pure water, okay? So milk is almost as non-acid as water, but not quite. You just don't eat that many bases, okay? In fact, I can't think of many things that are very basic that we tend to eat. We usually, just about all our foods are slightly acidic, because that's how we're going to tear them down anyway. But pure water is 7. Now, antacids, if you're having to take those for your ulcers or acid reflux or something, those would be 7, 8, 9, Tums, things like that. Those would be very basic, okay? So anyway, a very good blurb. I would highly recommend reading it. If you choose to write your paper on it, this can't be your source, but that would be a really nice topic, okay? There's another little blurb about dune angles. We mentioned the dunes on the last thing. Those are the low mounds, so you can read that. And it basically is talking about the angles you would have there. Now, when I was in Nebraska and visited the Sadi, okay, their ranch was in what they call the sand hills. And I never have quite figured out whether the sand hills formed as dunes or if they were deposited by glaciers. It may be a combination of both. I don't know. But I mean, huge hills, and they're not clay hills, they're sandy hills, covered with grass generally, and they graze the cattle all over them. You wouldn't even think of cultivating them because it's too steep. But anyway, that talks about the dune angles. And before we move any further, John Wesley Powell, okay? I don't know if I buy this. The most romantic figure of the 19th century U.S. geology. I didn't know U.S. geology was famous for romantic things. But anyway, they mean, I don't know. You can read this. He would be another good paper topic. And if you read this blurb here, you'll see several other names that you could also include. Grove Carl Gilbert, Clarence E. Dutton, W.H. Holmes. Okay? And then there's several other things you might find of interest in that. But again, this can't be your source. This can give you ideas for your paper. You need to get your source elsewhere. Okay. So now I think we're ready for development of landscapes. This, I think, is the last section yes, definitely in the chapter. Okay. Now, some of this may look like deja vu all over again, okay? Because you've seen a lot of this kind of stuff before. The landforms are the Earth's surface features, things that you notice, okay? There's the broad features, such as mountains, plains, and plateaus. Oak Mountain, Red Mountain, Shades Mountain, the ridges there. Those are broad features, okay? The plains are the valleys in between the mountains, royal features. Plateaus, okay? Those are elevated areas that are fairly flat on top. In western Georgia, which I'm sure includes some of eastern Alabama, there was a broad feature called the Fort Valley Plateau. Okay? Fort Valley, Georgia. I don't know if you've run into this, but some of the buses that they use to transport kids around, yellow buses, a lot of those were built in Fort Valley, Georgia. I don't know why they had a big plant there. I don't know if they still do or not. But it's called Fort Valley Plateau. That is one of the best peanut growing areas in the country. And so I bet you Alba, Alabama, and some of those places in eastern Alabama are still on that Fort Valley Plateau or related to it. Then you have the minor features. These would be the hills, the valleys, the canyons, things like this. Of course, the Grand Canyon would be more than minor. That would be a pretty major, broad feature. But most of your canyons and valleys are the more minor things. Okay? The generalizations that we have here, why do they happen? Well, number one is the rock structure. Okay? What was the underlying bedrock? In soil science, you call it the parent material. If it was granite, that is very slow to wear away. It does wear away, huh? Limestone is what underlies us, and it's far more rapidly, chemically and physically, worn away. Okay? So that would be what makes these different features. What kind of rock are underlying? Granite? Limestone? Sandstone? What is it? That will have a lot to do with what these features turn out to be. Then secondly to that, but related to that, is the weathering and erosion. Like I just said, physical weathering, that happens really easily on sedimentary rocks, sandstones and things like that. Chemical erosion happens pretty readily on the chemical sediments, like limestone, whereas granites are resistant to both of those. Okay? So you have weathering and erosion that occurs on either of those. And then the stages of erosion, whether it's severe or just beginning, those kind of things, that will help determine what some of these minor features and even probably some of the broad features may be. But it's determined by those kind of activities. Now, let's look at each of those. First, the rock structure. It determines the shape of these minor landforms. Okay? Now, the rock feature refers to what type of rock. I've already said igneous rock tends to be very resistant to weathering. The granites and these others. Metamorphic rock are pretty resistant to chemical weathering. Now, they can be fairly brittle, but they usually are as resistant and sometimes more resistant than igneous. The sedimentary rocks, my goodness, those are very susceptible to chemical and physical weathering, and probably to a large extent maybe some of the biological weathering as well. So the type of rock, that's going to contribute to the rock structure. Remember the pictures we saw of Grand Canyon? We could see the layers in there. That was all sedimentary rock. Easily eroded, and the Colorado River did it. Okay? Over centuries, it's done it. Okay? Now, some of these rocks have attitudes. No. The attitude of the rock means the effect of the disturbance by faulting and folding. Okay? What has happened to these rocks? Have they undergone folding? The Appalachians have, and that determines how they're going to erode in some of their landforms. Have they been faulting? Fault block mountains. The Rockies tend to be a bit more like that. What is their history and what is currently going on with it? The faulting and folding can hasten erosion. And I think we saw that in some of the pictures. When I said, notice the crevices here. These in the folding and the faulting, you got cracks. Where the cracks were, you tend to have erosions more. So yeah, the attitude, the placement of the rocks, yeah, all that contributes to what kind of rock structure you have, and then what kind of landforms you have. The weathering and erosion processes. These are influenced and controlled by two major things. Climate. And climate is made up of two major things. What is climate mostly made up of?
Climate.
Yeah.
Climate, like weather.
Weather? Yeah. What about weather? What two features of the weather?
Atmosphere?
Okay, your atmosphere for sure, but what two features of weather would determine how much erosion you might have or not?
Precipitation.
Second? Precipitation, exactly. The more rainfall you have, guess what? All the chemical weathering happens in the presence of water. So if when you have more moisture, you're going to have more weathering. Water also detaches and transports. It hauls the stuff away. So yeah, climate is temperature and water, moisture. Hot, dry regions, you'll have some weathering, but not nearly as much as you will in warm, wet regions. Cold, wet regions, you'll have some weathering, but not nearly as much as you have in hot, wet regions. Okay? Guess what we have? Hot, wet regions, okay? We have plenty of moisture and usually pretty high temperatures. Now, one thing we don't have, well, we do have some, elevation. The higher you go, the cooler it tends to be, but the more you're exposed to wind and rain erosion up there too. Now, the other thing about elevation is slope. The greater the slope, the greater the erosion. The flatter it is, the less erosion you have. So places like this, like I said, some of the mountains around here, we have great slopes, high rainfall, and warm temperatures. That's a bad combination to have. So your warm, moist climates, those are the two features, warm and moist. Chemical weathering dominates, okay? Because where moisture is, there you can have chemical reactions. And warm temperatures, you have chemical reactions, okay? Now let's think about that a minute. I believe I gave you, they sometimes call it the rules of 10, okay? Starting at 40 degrees Fahrenheit, this is just a rule of thumb they have for chemical weathering. At 40 degrees Fahrenheit, every time you go up 10 degrees above 40, you double the rate of chemical weathering. So from 40 to 50, you double the rate of chemical weathering. From 50 to 60, you double it again. So it's 4 times what you had at 40. From 60 to, it just keeps doubling. Guess what we have? Lots of chemical weathering. We have lots of rainfall and warm temperatures. Even in the middle of winter, we'll have many days above 40 degrees. Okay? We'll have some days that don't get above 40. Very little chemical weathering going on there, but guess what? Wait a week, it's going to change. Okay? You can guarantee that. So where that occurs, warm, moist climates, your landforms will have softer, rounded outlines. Go to the Smoky Mountains sometime. You'll notice most of those mountains are rounded mountains, you know? You don't have real sharp peaks. Go out west to the Rockies, very jagged peaks, very different landforms. In the dry climates, mechanical weathering dominates, not chemical, mechanical, okay? And there you have the sharper, more angular outlines, much more common, okay? So that's the weathering and erosion processes, how they affect the landforms. And this is the part you'll say, wait a minute, we've already done that, been there, bought a t-shirt, okay? And this would be the stages of development describe the cumulative effects of these formation processes. If it's youthful landforms, the weathering and erosion effects are just in the beginning stages. Generally, your mountains will have very steep peaks, narrow, steep valleys. Remember those pictures of Yellowstone? That is a fairly recent landform compared to the Smoky Mountains. Very recent compared to those, even though they're thousands of years old. That's recent geologically. Very steep valleys. The mountains, steep peaks, okay? Those are youthful landforms. Mature landforms, the original structures have worn down, rounded the peaks somewhat, made the slopes more gentle, okay? We saw this in the stream bed formations. Same type of wording they use for landforms. In the old age, okay, the characterized by nearly flat and rolling plains. And here are a couple of terms. These are sort of like those crystals that we talked about. I don't think I've ever seen them anywhere else, but here they are. Peneplains, nearly flat surfaces. I don't know if this is fair to talk about, but when I think of Auburn, Alabama, and those kind of areas, I mean those are really flat type kind of areas. Okay, nearly flat surfaces. Whereas monadnocks would be hills of resistant rock. Okay, you have a pretty flat area, but then you have this one hill that just won't erode away because it's that resistant. Yeah.
Are those like the kind of hills or cliffs where the rocks are kind of sliding off the side?
Okay.
Sliding off rock slide.
Yeah. Yeah. What was that? Yeah. I missed the first part of your question.
Are those those type of mountains or cliffs where they have the rocks slide at the bottom?
Those would typically be more here where you have greater, steeper slopes. That would be where you have rock slides much worse. And they do. They do have pretty severe rock slides. And when they get heavy snowfalls, they have avalanches of snow. So yeah, that would be more the youthful. You have some immaturity, and in a few places where you have the big, broad monadnocks, you may have some of those too. But that would typically be more here. Okay? Or in places where man is intervening. Like we made a road cut through a mountain, and then you could have rock slides down the mountain. So that was more caused by us than would be naturally occurring. Now, as we've said at the end of just about every chapter, even though you notice all this stuff, everything's always changing. You always have rejuvenation. The land is uplifted, then the erosion process will begin again. Even in these old plains here that are nearly flat, you'll still have plate tectonics going on. Things are being lifted. I mentioned to you, in fact, we pointed out the basalts, the mountain basalts out in the far west. How do basalts get up in mountains? Well, you have uplift, and now you have erosion starting all over again. Those basalts were formed at the bottom of seabeds, okay? Where did they, how did they get up here in the how area? Things are always changing, okay? And that's, they refer to as uplift. That's the last slide, end of the chapter. Oh, isn't that sad? Okay, they do have some other pretty pictures here. One is a melting glacier. This is figure 2016. Up top is the melting glacier, source of stream that shows below, flows through a valley in the youthful stage. How do we know it's youthful stage? Look at those ridges and peaks. The valleys are pretty steep, V-shaped valleys. Still lots of rock in sight. Some of the peaks look a little more rounded. That would be more mature area, but the higher elevations, they would be more jagged. Now, I think the last chapter I commented on how short the summary was. This one's even shorter. I mean, this is one of the shortest summaries I can recall in the book. And when you look at key terms, 9, 10, something like that, pretty few compared to what some chapters have been. They do list the page numbers where they were either defined or first mentioned, so you can find it there. Applying the concepts, 45. That's probably a little below normal also. So that's, to me, one of the best things to study for your test, the applying the concept. The answers are given. So you go through and see if you can estimate what you think the answers are. Look, see how you did, find out why you missed what you missed. If you can't figure it out, bring it to class and we'll talk about it. Now, questions for thought, though, 18 of those. That's probably normal or a little few more than normal.
Give me that before I forget.
Good deal.
So do we have questions to answer and turn in from this chapter?
No, you don't have to. It's just a good thing to study.
Okay.
Yeah. Okay? Yeah, there was one of the labs we did. The one on... That sounded like a good suggestion, didn't it?
No.
Okay. All right. Okay. No.
Yes, they voted for it.
For further analysis, there's only 3. I can't remember many chapters of that few. Okay? All right. Then there's invitation to inquiry. And by the way, those are not bad things to do to study for your test. You may not have to write them out, but I would definitely go through those and study.
You gonna give us a test to say with?
What's that? I think someone's dreaming again. Wake up, wake up. Okay. All right, parallel exercises. A lot of these are sort of thrown in. I don't really know how pertinent they are, but they are there if you want to look at them. All right, now, do most of you have the big books? Do any of you have the real thin, skinny books? I don't think any of you do, okay? So if we do finish in too much time, and I don't think that's going to happen, we could go back and pick up chapter a little bit in 21 or 22. 21 is geologic time, which is all interesting. It has a lot of interesting things. You can pick your paper topics out of this, fossils, for instance, or things like that. It is some pretty interesting thing. Petrified wood. There's lots of very interesting things you can look at here. And you can write your papers on it. That's 21. We're not going to do it in class, but anything in there. There's Edward Seuss, not doctor, but the other guy. He would be a decent paper topic. Okay, there's several things you can look at there. Not a very long chapter, but we just don't have time to do it. Okay, we didn't even have it, and that's why I asked about the thin books, because they weren't even. We didn't have it. Now, yeah.
Your next science class, because I had to take you apart too. You're going to use the same book?
Yeah, same book for that. Now, the one that you'll see in the bookstore for it, we haven't made book orders yet, but the one you'll see in the bookstore, they'll go to the thin ones again. See, they ran out of those, the company quit producing them, and then they had us do them on the newer edition. But you can keep this one. You don't have to buy that other one. We'll do the first half of the book for the other science class. Okay. Now, here's part of the reason I went through all that. Moving on to chapter 22, the atmosphere of the earth. I really wish we had time to do that, because this is what chapter 23 is based on. So if any of you want to read or at least scan, chapter 22, that's going to help you understand what we're going to be talking about in chapter 23. So I would say not a bad idea to look at chapter 22. Okay? You're not responsible for it, but it will explain a lot of the stuff and prepare you for what we're going to do in 23, which is what we're going to start now. Okay?
So is there a reason why you never do 23?
Well, the reason is we really don't have time. See, I need to get in, because of the course description, weather and climate and Earth's waters. So I do those 2 chapters next, and if I have time, I come back and pick up one of the others. But so far, I've never been able to get that. This class has moved on at a pretty rapid pace, but now with next week being taken up mostly by labs, maybe, we won't have a lot of time to do. We may be really pressed to get chapter 24 done. Hopefully we will. It's a very interesting chapter. Okay, but you can look at atmosphere. Okay. Now, let's move on to chapter 23. Weather and climate. Okay. Oh, man, what did I just do? I just was talking and just completely shut down what I meant to open up. All right. All right, chapter 23. Well, I can't see it's doing anything. It's wiggling a little, but that's all. Let me try it again. All right, here we go. All right. All right, chapter 23. Weather and climate. Is that sort of redundant?
Kind of sounds like
It does sort of, doesn't it? Is there a difference, or is that just two ways of saying the same thing?
well, it's like day to day. Yeah.
Ah, very good. Weather is what's happening now. Okay? Climate is what's happened over time. Climate is a much broader type term. Weather are specific events that we deal with now. Okay? And we'll do it this time in the order that it's given. We'll talk about weather first and then climate. Okay? And that really fuels a lot of the misunderstanding about climate change. Okay? People say, oh, we had a cool summer this summer, so that means there's no climate change, right? Well, one summer is just a point in time. It's not the big picture is, things seem to be changing rapidly. So, we can't use weather to talk about climate. They're related for sure. Okay? Here's the core concept. Shows up on your page 573. Solar radiation, well, this says solar energy, okay, drives the cycles in the Earth's atmosphere. That was what chapter 22 was talking about. And some of those cycles determine our weather, and the history of those cycles and long term determine our climate. I put in a few extra words there. Okay? Anyone know what this is a picture of? Pretty much, it's taken from probably a satellite.
Like a hurricane.
Okay? Actually, this is the Gulf of Mexico. There's Florida, the Florida Peninsula. This, I think, is Texas. That's probably part of the Yucatan Peninsula. I think that's Cuba right there. Now, it's not completely because you get some shadowing because of cloud cover and stuff like that. But that's basically a big, way overhead shot of basically the Gulf of Mexico. And we'll be looking kind of at big picture type stuff. Now, in your text, you just have a real pretty picture of a beach area for in the newer book. So let's talk first about clouds and precipitation. That's the weather makers here, okay? And if you think about it, how many chapters have dealt with cycles? The rock cycle, here's the hydrologic cycle. Now, what is hydrologic? What does hydro mean? Water! So this is and logic comes from logos, which is learning about or story of water. It's the hydrologic cycle. Now, you can, because it's a cycle, it's just a huge circle, so you can start it anywhere. Let's begin with the ocean. lots of the surface of the earth, the vast majority of the surface of the earth, covered with oceans. So let's start there. Oceans are there, exposed to the sun, very few shade trees on the ocean, right? Okay, so exposed to the sun, and the sun evaporates the water out of the ocean. In fact, that's what makes the oceans salty, because the water evaporates away and the salts that have washed off the land, they stay there, and that's why the oceans become salty. Okay? So you evaporate the water from the ocean. These go up into the air. Somewhere up there they hit a cooler band of temperature, and then they start condensing and form clouds. The clouds, under the prevailing winds, wherever they happen to be, are carried. Some of that is because of the earth spinning, and some of it is, other reasons as well, but mostly to do with the earth spinning. But anyway, the clouds are moved. Now, some of those clouds move over other parts of the ocean, and they rain there, and you have a short circuit on your hydrologic cycle. But those clouds that make it all the way to land, and then they precipitate or rain, then the water hits the soil, and one of two things could happen. It either gets soaked into the soil, we'll talk about that in the next chapter, or it runs off the soil, a lot like we talked about in the last chapter. But then ultimately that water makes its way back to the ocean, and we start the cycle over again. So that's basically the hydrologic cycle. Evaporation from the ocean, transport through the atmosphere via the clouds, condensation and precipitation. That could happen over soil, water, land, wherever. Some of that precipitation could be rain, some of it could be snow. Some could be hail, but there's not usually lots of that. Okay? And then ultimately it returns back to the ocean. Okay? Now, there's certainly many smaller subcycles, like when it comes up and then rains back into the ocean directly. That's really a short cycle. Okay, a short circuit there. Other times the water goes into the land, maybe stays in the groundwater for years or decades or centuries, and is pumped out and reused on the land or used in things. But ultimately, the water makes its way back to the ocean. Sometimes long time later, sometimes very short period. And then, too, some of this goes back into a lake and then evaporates from the lake and goes. So it doesn't have to be the oceans. You can have other subcycles there. We'll talk about that more in the next chapter. Okay. Is there any moisture in this room?
Yep.
Oh, yeah. Okay. In fact, I swear, the last several weeks, the temperature will drop either in the late evening or it will be still pretty cool in the early morning. And I want to open the door because it's cooler outside than it is inside. And my wife will say, "But close the door, it's so humid out there." And sure enough, most of the days it is. 90, 80-something% humidity. And it just feels so sticky even though the temperature is lower. Well, what we're talking about, the air has moisture. Okay? Now, I don't know if any of you have ever lived out west. I haven't, but I've driven through it. And I tell you, I cannot handle that cold. Yeah, dry heat. Boy, my system is used to moist air, okay? And boy, it dries out my sinuses. It's a mess. Now, people out there, they come here and they can't handle it because of all the humidity. But you sort of get used to it one way or another. But the moisture is in the air, okay? What is it that makes clouds? The clouds form when the air masses, and we'll talk more about that later in the chapter, are cooled to their dew point. What in the world do we mean by a dew point?
That's the point at which dew forms.
Okay, that the moisture actually comes out. Which will hold more moisture, warm air or cool air? Oh, for sure. That's why we call it hot and humid, right? Let's see, what is it? Getting close to. Do we need to?
Yeah, I think it's
Yeah, let's take a quick 5-minute break because it's. Yeah. Well, you don't have to take 5. Come back sooner if you want to. Huh? What's that?
You said 15.
No. No, go ahead. Hey, you were leaving. I'm saying let's take a break.
Okay, let me go.
Now, wait a minute. When we're having class, she's going to leave. Oh, okay. When I say take a break, she comes back. I don't understand it. Okay, let's do a quick break, and we'll come back to this slide today. But this weekend turned out to be pretty much not a disaster weekend, but it just nothing. I got very little schoolwork done. I'll put it that way. Friday, I had a major problem happen, and I was late getting to work, and that's when I usually get my grading caught up. So that shot the first part of the morning. Then the dean called a meeting for the latter part of the morning, and I had to get prepared for the meeting, and that took the middle part of the morning. So I got almost 0 graded on Friday, which is my big grading day. Okay, so I took it all home with me over the weekend, but we were out of town over the weekend. And part of that, I probably did sort of waste some of the time, but it just, I needed some downtime. But the rest of it, I was working like a dog out. It was fun. I enjoyed being outside, but when I come in, I'll just be exhausted, okay? And I'm still sore from it. So it was a good weekend, but it was not good to get papers graded. And then yesterday, I had some time in the office, and I got a fair amount graded then, but I didn't get I got about half of this class caught up, but not the other half. So I'll try to do some of that today, too. And then tomorrow, I'm giving a test for Dr. Thomas, but I hope to be grading papers while I'm giving that test. And then Friday, I've got an infusion, so in the time that I'm sitting around waiting, I'm going to be grading papers like crazy, too. So.
Transfusion? What did you say?
Huh? An infusion. I told y'all early on that I have a form of leukemia. I have to have chemo about once every 2 months. Yeah, every 8 weeks. It's not anything serious. It's just it's a monoclonal antibody, and it's just something to knock down the number of the bad cells. So, but it takes all day. I mean, I go in at 8 o'clock, so I go in before 8 to get blood work done, and I go in at 8, and it's a slow thing because monoclonal antibodies are developed in animals like rats, mice, things like that. So they have to try to filter out as much of the foreign material as they can, DNA type stuff. Huh? Yeah, they use it. Yeah, that's what they use it for. And they try to, and so they have to administer it very, very slowly, so you don't have a, what do they call it? Reaction. Yeah, reaction. They have a name for it. But anyway, so they have to do it very slowly. So they give me 2 steroids, they give me Tylenol, they give me Benadryl, and all that to knock. Oh, the 10 o'clock scholar! Why did you come so soon? Okay, glad you're here. Anyone else come in since I called roll? Okay, so anyway, I will have some time on Friday to get grading caught up. I hope to get a lot of it done beforehand, but I'm behind in grading right now. And we got spring schedules coming up really soon, and we got book orders coming up really soon, so it's not going to get any better. All right, that was my sad song, wasn't it? Terrible. Okay. So, all air contains moisture, okay? The warmer the air, the more the molecules move, the further apart they are, so it can hold more moisture, okay? And then when the air cools, though, if it has lots of moisture in it when it's warm, when it cools, then at some point it starts condensing out. That's when it reaches the dew point, okay? Now, a very moist air, dew point is going to be very high, okay? Pretty dry air, the dew point could be really, really low, okay? But clouds form when those air masses are cooled to the dew point. And like I said, remember the first picture, the evaporation from the oceans? That moisture is going through the air. Boy, you know that near the ocean, everything's humid. Really, really humid. It goes up into the atmosphere, and at some point up there, it reaches cooler air. And when it reaches cooler air, it starts condensing out. That's when clouds form. Okay? So clouds form when the air masses are cooled to their dew point. Generally, they're cooled by that upward movement. Now, there's three different upward movements you have. I mentioned convection. Okay? Warm air rises, right? And cool air sinks. So when that warm air is rising, that's the upward movement. Okay? Until it reaches the place where it's cool enough to reach the dew point and cloud form. Coming over land, however, if the moist air from the ocean is coming over land, they may hit mountains. And mountains, the higher the elevation, the cooler it is, right? So at some point, they reach the dew point. So the barriers, like mountain ranges and things like that, that may cause the upward motion. Okay? Now, remember we talked about the west coast, how the subduction of the oceanic plate underneath the continental plate, and then you have all these mountains that rose up there because of volcanic activity or faulting and things going on at that boundary. Because the west coast, I mean, there's some places it's almost sheer. I mean, you go right into mountains right off the ocean. And in some of those areas, just a few miles inland, it's drier than toast, but on the outside of the mountains, it's moist. Seattle, Washington, one of the wettest areas in the country. But you go inside the mountain range into eastern Washington, very dry area because the mountains blocked all the moisture. Okay? Now, the other way that you have the upward movement is when you have colliding air masses with different densities. Usually cooler air is more dense than warmer air, and if warmer air is coming off the ocean, you have a cold front here. When they collide, the warmer goes up, cools off, and that's when the clouds form. So there's three different ways that you have that upward movement. Natural convection, barriers, physical barriers, and colliding air masses. The cloud formation depends on the atmospheric stability. Now, you'll hear the weathermen and women say all the time, oh, we have unstable air or very stable air. What in the world do they mean by atmospheric stability? Okay? Now, if we get to go to Channel 13 and Jerry Tracy hosts us, he uses this example, so stand by for it. He said, now, some of you are old enough to know who Arnold Schwarzenegger was, right? Yeah.
I'll be back.
Huh?
I'll be back.
Yes, okay. Jerry says, if Arnold Schwarzenegger would come, and now he's getting too old for this now, but would come and lift me up, that wouldn't be much of a problem. But if I were trying to lift up Arnold Schwarzenegger, that would be a big problem. That would be an unstable situation where Arnold Schwarzenegger holding him up would be a fairly stable situation. Well, here's what it is. The lifted parcel of air is cooler and denser than the surrounding air. Now, it doesn't seem like it would be lifted, okay, and it doesn't seem like it should be stable that way, but it is. So what it does, it tries to return to its original level because it wants to go where it's best. If it's denser, it doesn't want to be lifted, it wants to go back down again. And if it happens, that forms a stable situation. However, the unstable atmosphere is when the lifted parcel of air is warmer and less dense than the surrounding air, and it wants to just keep lifting. So it moves to a higher level, continues to rise, and these are called your thermals. Okay? We didn't see much of it this time. We saw a little bit, but sometimes when we've been out west, and we don't go there often, but we have been a few times, and the hang gliding people, they will go up on the mountains, and they do it with someone who knows what they're doing. They'll have these big parachute-looking wing-type things and just running off the side of the mountain. And what they try to catch are these thermals, where the warm air is coming up off the thing and ride the thermals. If you've ever seen a hawk, an eagle, seagulls do this all the time, just hang in there with their wings outspread and let the thermals just carry them along. They're not flapping their wings at all. They're just moving with the thermals. Okay? That's what you get there when you have that lifted parcel just keep going up. Now this illustration, it's fine. This is a stable atmosphere. I find it not particularly, I deal with grass all the time. I don't find this one particularly revealing. I'll put it that way. Okay? So here we have increasing air temperature is going here. The temperature of the surrounding area is here. The parcel of air that's being lifted is less dense than the surrounding air, cooler than the surrounding air, so it wants to come back down. Okay? So it's lower than this, so it's wanting to just settle out. Okay? That's a stable situation. Nothing is going to really be upsetting in that situation. But, and again, I like Arnold Schwarzenegger's illustration better than these. In this case, the surrounding air temperature is like this as you go to increasing altitude, but the parcel of air that's being lifted is warmer than that, and it wants to keep going up. And when you have this thermal, this going up, you tend to have an unstable situation because air has to come down. This forms what they call a low pressure. Okay? And when you have air moving like this at pretty good speeds, that's when you sometimes have circular motion begin. And even if it's not circular motion, you have situations that are conducive to thunderstorms and severe weather, high winds, that kind of stuff. Okay? So this is what they call the unstable situation. The parcel of air just wants to keep climbing. And as it climbs, then it's pulling other air up with it, and you have too much movement going on. It's not that stable situation where things are settling down. It's actually getting worse. Okay. And if that has a lot of moisture in it and keeps climbing through that, that moisture is going to condense when it finally reaches a place where it's cooler, because this gradient is always going to be like this, and then you could have really hail, and lots of other situations like that. We'll talk about that later. And again, I don't find that this illustration is particularly insightful, but it is true. Read the book. You probably get a little bit better from it. Okay? So that's, the first one we showed was figure 23.3. This is 23.4. Okay. The example 23.1 that's given in the text is a great example, but it's based on stuff that we haven't had. That was back in heat and temperature chapters that those of you who take the second course here, from the first half of the book, you'll see, oh, we could have used that then. Well, you could have, but we haven't had it, so we're not going to do that. All right, so that's your atmospheric stability. Okay. Everybody got it, or anyone still writing? Okay. Now, let's continue this upward mobility and moist air. This is still, I think, in that cloud forming processes there. I just don't see exactly where it is in the text. The rising moist air ultimately is going to cool, eventually reaching the dew point. Okay? Now the droplets condense, but they have to have something to condense around. If they don't have some type of particulate up there for them to condense around, they become what we call supersaturated. If there's no condensation nuclei, you get supersaturated air. That's not very stable either, okay? But if you have a condensation nuclei, now what would be the condensation nuclei? There's several things. They could be dust particles. They could be salt grains. They could be anything such as that is going to attract the moisture, because the air is getting heavier and heavier with moisture, reaching its dew point, it's wanting to come out. If moisture can find anything to grab hold of, it's going to start forming the little droplets.
So it's latent heat you feel, correct?
Yeah, okay. Latent heat is that you don't feel.
Okay.
Sensible heat is the heat you feel. Okay? And you're right on the money there. Latent heat, when it changes from a gas to a liquid, that's condensation, it gives off a lot of energy. That's latent heat. Okay? It's all at the same temperature, but it's releasing energy. Okay? When it's changing temperature, like when it's rising and the temperature is changing, that's sensible heat. Latent heat is when it actually condenses. Okay? It's the reverse of the process. Tiara's here. Okay? And Trey's here. We're only missing Kedrick. Only person missing. Okay? So, somewhere up there in the air, the moisture has to find these condensation nuclei. That's what they condense around. If they don't have any, they get supersaturated, and in time they're going to really start coming out there. The cooling of the rising air is slowed by and this is where you got latent heat, because you see as it changes from gas to a liquid, it gives off heat, so that cooling of the rising air is slowed by release of latent heat of vaporization. It's heat, but it's not a temperature change, it's just heat provided in the atmosphere, and that then produces. Now, I don't know, when you, if you've lived in the South very long, you probably have experienced a few snowstorms. Not very frequently, but a few. There was one winter I remember several winters ago, we had like 4 or 5 snowfalls. Unheard of, okay? And some of those were pretty heavy. 1 or 2 were. I remember one when everybody got stranded. They were calling for a light dusting. It was more than a light dusting. Happened right in the middle of the day. All the streets froze over. People couldn't get home. It was a mess, okay? When we've had those, and the next day, and this happens in the South frequently, the next day or two, it gets bright looking outside, it warms up, but you go outside, it still feels cold. Why is that? Because that snow is melting back to water and absorbing, not releasing, but absorbing latent heat. So even though the temperature of the air seems warmer, all that temperature goes to melting the snow, and it really doesn't feel much warmer at all. And then when it all finally melts, and suddenly it feels nice and warm. Okay? That's also sort of what happens when you have a rainfall, and that rain starts evaporating off of you. That's why you get chilled when you're in a rain, right? Because of what water droplets. In fact, that's exactly what your air conditioning system does. I mean, what is your body's air? Yes.
Why there's a possibility of getting colds in the rainfall?
Say this one more time.
Is that why there's a possibility of getting a cold during the rainfall?
Okay. Now, if you ask me that, I can give you an answer. If you ask a medical professional, they'll say rubbish, because they say colds are caused by viruses or bacteria. Why would you expect there to be more viruses or bacteria in a rainfall? You don't. But, on the other hand, you're exposed to viruses and bacteria all the time. If your resistance goes down because you get chilled, and your body is having now to send energy out to warm yourself up and not to fight against the germs that are already there, that may be cause for cold. So I don't know. I don't think anyone has a real answer to
Yeah,
that.
'cause I heard those are good.
What's this?
No, like, you know how people say you get cold from being cold?
Yeah.
That's not true. Like,
Well, that's what I was just saying. Cold, talk with an infectious disease person. They say cold doesn't create colds. Colds are caused by viruses and bacteria.
because,
Yeah.
like, I heard that, that's why the hospital has so cold because cold weather kills germs. Is that not true?
Okay, yeah. Actually, warm, moist environments spread germs, grow germs better than things. But you see, a hospital, though, you got germs all over it because you have a bunch of sick people in there. So you have what they call nosocomial infections that people get. Those are hospital-caused infections because they're in a place where there's lots of sickness and germs. So a lot of times it's far healthier to get out of the hospital than in. So once they've taken care of the major thing, get the people home, okay?
But see,
Yeah. So again,
you can get cold, like you can get sick from going in and out of the cold, like
Right.
from warm temperatures to like really cold.
Right.
You can get like pneumonia from that, right?
well, again, people say pneumonia is caused by germs. But what I'm saying is you've got the germs in you all the time. Your body's fighting them off all the time. If you're going from an environment warm to cold and warm to cold, then your internal body's thing is having to readjust like crazy, and it's not spending the energy fighting the germs, but now the germs take over. So I think that's where it comes from. Yeah.
Oh, I just wanted to say it would make sense for the cold, for you being cold and not in your immune system or whatever, would
Right.
be able to fight off germs because doesn't heat kill germs anyway?
Okay. Yeah, but you usually have to get above the boiling point, and I don't want to be in that environment.
It's
So,
like he said, like she did, like, okay, I guess it depends on the bacteria. Like,
Right.
food, I'm sure cold can kill, like, food, bacteria that come in, like, chicken, coli, and stuff like that. But I'm just confused about it. I thought he incubates, like,
Yeah.
grow.
germs grow better in warm, moist conditions.
So germs, the bacteria in food is different from what we're talking about right now.
No, I mean, same thing.
That too long we'll kill, like we're boiling point.
When you get to the boiling point, then you start killing them. But there are sorts of bacteria you have to get well in excess of the the boiling point. Like Clostridium, it seems like is one that will endure even at boiling water. You have to get it very hot boiling water. In other words, superheated water before you go and kill it. Or put a little chemical in there that'll kill it or something. So yeah, it's really tough. But yeah, they die off at very high temperatures and they don't multiply fast at very low temperatures. But in between, the warmer the temperature, the more they proliferate. As long as you're below that threshold. Yeah. And but I think a lot of it is your immune system. And if your immune system is distracted because your body's having to suddenly create, and that's what it seems like to me. I can remember times when I've been outside sweating in pretty cool temperatures, but working real hard and building up the sweat, and then cooling off too quickly. It seems like I'm going to catch a cold. But the germs were already there. It's just that my body went one way and then the other too quickly, and the body couldn't adjust, and the germs won.
Let me ask you this, because I know the doctor said, especially if I've been living in Alabama,
Yeah.
like they say you go to Florida, like the atmosphere is different. That like if you have a cold or something, and you used to go to Florida, then I don't know, I guess it helps.
Okay. It just depends.
What's that like?
Try it out.
Yeah.
I mean, the atmosphere is more like,
Yeah.
I don't know, clear. That's what a lot of people say. Like my family is always like, I'm ready to go to the beach because it's clear, the air is clear, and it helps me with my sinuses.
Right. Okay. Now I was going to say people who suffer from asthma, quite often if they go to a warm, dry environment like Phoenix or someplace like that, your airways don't swell as much and stuff, and you have a lot less problem with that. So yeah, there are a lot of competing factors going on, but usually this is one of the worst environments. Warm, moist environments. Germs proliferate. They love it here, you know. But a drier environment, then the germs will not have this. Yeah, they don't like that as much.
So Florida is like more like.
Florida can be very warm and moist too, but whereas you get very cold. Okay. A lot of the reasons people get colds in the wintertime is because you're inside. And when you're inside, you're recirculating all that, you know, you're rebreathing the same air, and people in the rooms with you, they could have a cold. Even though they don't have the cold yet, but they've been exposed to it, they could be shedding viruses and germs, and then you're getting exposed to that. When in the summertime, you're outside more and stuff. So that's why going to Florida, you know, year-round, you're usually outside more, and you're not cooped up inside. Whereas when you're inside, the extreme of that is being on an airplane. Now, my wife is in infectious diseases at UAB and at Children's Hospital and pediatric infectious diseases, and she hates being in an airplane. She has to travel all the time, but if anyone coughs in an airplane, she said, "Oh no!" She starts covering her mouth, you know, and getting out the hand sanitizers and stuff, because in an airplane, all the air is recirculated to everybody. It might be in the back of the plane, they're sneezing, in no time it's going to be, and it just drives her nuts, you know. And the same thing happens inside. Whereas really, in these old leaky buildings, we're probably better off than in way up north where everything is built really tight and you're circulating all the air. You're just breathing. And then too, what happened in Philadelphia, do you remember the Legionnaire's disease? It was actually the cooling towers was where that bacteria was growing, so all the air was blowing across that, recirculating into the building, and they had a really bad outbreak of, I can't think what the thing, but it was a bacterial disease. I mean, just the whole hotel got sick, you know. And, you know, cruise lines, you know, Royal Caribbean and these cruise ships, if someone comes on board that with, say, a stomach virus and they don't even have any symptoms yet, that's just right for everybody getting it. And that's why they'll have those outbreaks so frequently, because you just jam so close together, you know. So my wife doesn't want to take cruises ever, which is fine with me. I was in the Navy. I had enough cruises. You know, so.
What was that disease that was going around? It wasn't
Pink virus?
no, it was something.
Or I was just like, the one that like kills you like 2 days.
It's something like it was something like that. It wasn't nothing like I don't know if it's not what say, but it was like an epidemic. It was like probably like 2 years ago.
Mm-hmm.
Zika?
Yeah, Zika virus.
Zika virus?
Is that what the person in the hospital, like a person came?
Oh, no, Ebola. Ebola, yeah.
I was literally just thinking that.
So what was that like? Was it how was it even?
Okay. You see,
Was it airborne?
yeah. And what the problem with that is, that was a disease, and most of the ones that are really bad are those who have cross species. And I can't remember what the species that was the original Ebola, whether it was monkeys or something, and it crossed over into, and you know, one of the worst flu epidemics we had was swine flu, and then we had bird flu. When they cross over and get to be something that infects us, where before it wouldn't have bothered us, then suddenly our immune systems have no defenses for that. And that's why they're epidemic and pandemic, because our, you know, it's crossed over. And Ebola was like that. It came from some other species. I mean, HIV is somewhat like that. They think it came from monkeys, I think, and swine flu. You know, it's been transmitted by poorly cooked chicken, because a chicken can be very susceptible. Well, a chicken can carry the virus and not show any symptoms. But if the virus gets in us, we are sick, you know, really, really sick. And that's bird flu. West Nile virus, I think, comes from birds too. if they find dead birds in the neighborhood, they really get worried because something like that. So Zika did it, Ebola did it. I mean, these are things that come from some other source, and we just don't have an immune system. But then when we get exposed to someone who has it, it crosses person to person. So.
Is that the kind of stuff your wife researches?
Yeah.
What's that?
Those things? Is that what your wife researches?
Yeah, she's in infectious diseases. She's focused mostly on cytomegalovirus, which is a herpes virus that's transmitted. You, me, I probably have already had it sometime in my life because I'm old enough. But if it were to contact us, you might feel like a very mild case of the flu. Might feel a little bad for a day or two, and then you're over. No sweat. But if a woman is exposed to it when she's pregnant, she may not have any problem with it, but if it passes to the fetus in utero, that fetus could have severe hearing loss or mild hearing loss. It could get, may have no response. It could have macroencephaly, microencephaly. I mean, there's all sorts of things that could result in death. There's just it's probably the number one congenital disease that is passed around, and there's absolutely nothing we can do about it except try to prevent it. And because we don't have a vaccine for it, and it's far more, it has so many of the same symptoms as Zika does, but you see, Zika you can spray for mosquitoes and do that kind of stuff, so everybody got real upset with that, but cytomegalovirus has a lot of those same things, greater prevalence, and yet there's not much we can do about it, so people just sort of ignore that.
Nobody's really talking about that, though.
Yeah,
You know
I
what
know,
mean?
exactly.
Like, until you mentioned it, I have no knowledge of it.
And most of the time, if a set of parents have a child with it, they'll say, "Why didn't someone tell me?" And there's not a good answer to that, you know.
So is that not, you said that's not a vaccine. So when stuff like that happens and it's not a vaccine, I mean, why, I mean, I'm just confused. That stuff like that confuses me.
Yeah, well,
Like,
what you have to do, and Karen goes into this all the time, she's in public health, and the most important thing is to wash hands a lot, especially after you've handled a child's body fluids, or your own, or anybody else's. Wash hands a lot so you don't transmit it, you know.
To a child, like, don't let like hold it.
Yeah, and actually, and this sounds really bad, but you tend not to want to kiss babies in the mouth. Even though you want to do it, don't. Because, especially if you're pregnant with the next child, if that child has picked it up playing with its friends, and then it transmits it to you, you can pass it on to the child. So there's all these kinds of things that they suggest that you not do, and it's pretty important. And if we did it, you know, it's in places where, in societies where better hygiene and stuff like this happens, usually you don't have as big a problem with it, you know. So it's where people don't pay attention and stuff like that, it can really run around. So yeah, there's so many factors. I mean, so it can be really devastating, perhaps.
I have another question for you.
Yeah.
I'm sorry. Since we're on the discussion, is hand sanitizer really that effective, or is that just a ploy to?
Yeah, I don't know the answer to that. I'd far rather wash and with soap and water my hands. I don't like hand sanitizer, but it's better than nothing.
But
It's
soap doesn't have any type of like allergen. You know what I'm saying? So what? Soap, not all soap has antibacterial in it.
okay.
But it's just
Okay.
working.
The
Like,
main thing that soap does for you is it's a surfactant. It removes the stuff from you. It breaks the bonds that it's holding onto your skin and washes them away. That's what it's doing. That's what you want it to do. This is not getting rid of them. It's trying to poison them with alcohol and stuff like this. And it's okay. I just don't like the feel of it and the sense that I'm putting chemicals on my hand. You know, I'd rather wash it and clean it up. Yeah.
Hand sanitizer trying to break it apart, but soap or wash it off.
yeah. But then
And you do have some soaps that are antibacterial, like your
Well, like soft, yeah, you're right, you do. But like a lot of people, I mean, if you go to Dollar Tree and get some soft soap, a lot of people don't really pay attention to it. They just take soap and soap.
Yeah.
Yeah, but I'm just saying.
But the main thing is you wash well and get it washed off your hand.
Did you ever do that thing in school when you go and they put that stuff in your hands that like resembles germs or something, and they put you under the black light before you wash your hands, and then they make you wash your hands,
Yeah.
and then they show you how it removes everything off.
Bring your wife in so we can talk. This week I want to talk. Yes.
Yeah.
That'd be pretty interesting.
Yeah.
Find out how much we don't know.
Yeah. And she's a much better teacher than I am, so you would do quite well. The cooling of rising at a slope by the roots. Okay. Huge numbers of droplets. When you get these droplets forming, and they're forming mini microscopic droplets, very small, and as more and more form and coagulate and stuff, that's finally when you start seeing them as clouds. Okay? That's what a cloud is. A bunch of those drops gathering together, that's what makes a cloud. Now when you go, yeah. Is there a question? When you go out and see, yeah.
Some, when it rains, some drops are bigger than other drops.
Yeah. Okay, yeah, we're going to talk about that a little bit later, so if you can hold the thought, you want it now, okay? Yeah. In severe thunderstorms, okay, we'll show this later. What happens, the water goes up, you remember that unstable air? It's moving up into the clouds and going to elevations where they actually freeze. And when they get heavy enough, they start coming down, but then they're picked up and carried up, so they freeze and keep getting bigger and bigger until they drop as hail, but on the way down, they melt, and that's what forms those huge drops. And a little shower that comes up in the day, those are just little droplets coming straight out. So yeah, you're absolutely right. In fact, the mist, the drizzle, and stuff like that, yeah, tiny little droplets. It's just then the nuclei, the little droplets are falling down. In the big thunderstorms, they've gone through this cycle and built bigger and bigger, and finally they fall. And those are huge. I can remember splats of rain hitting a windshield and be on trips. I mean, it looked like it would be that big around you by the time it hit. And it would surprise you, especially if it's been, not raining, and then all of a sudden these big drops hit the windshield, almost scare you. Okay. But y'all are right on. Okay. So, what's the origin of precipitation? In fact, what is precipitation? Okay? Precipitate. That means to fall. So, precipitation is anything falling. Let's go back to chemistry for just a minute. Okay? I can remember the first chemistry lab I had at Georgia Tech, the first quarter freshman. We mixed silver nitrate, which was a clear solution, with calcium chloride, which was in a clear solution. And as soon as we mixed them together, white particles fell out. That is called a chemical precipitate, because the silver combined with the chlorine, silver nitrate was soluble, but silver chloride wasn't. So when it combined with the chlorine, it fell out of solution, precipitated out. That means to fall out. That's water returning to the Earth's surface from somewhere above. That could be rain. It could be snow. It could be hail, okay? But dew and frost are not precipitation. That's the warm, moist air during the day. The temperature drops at night, and that the moisture in the air doesn't precipitate out. It just comes out of the atmosphere. That's what forms dew in the summertime, or warm weather, frost in the wintertime. Okay? It's not a precipitation. It's a surface process, not precipitation. But rainfall, snowfall, hail, anything coming from high, that's precipitation. It means to fall. A precipice is something you can fall down. Okay? So that's what precipitation. Precipitation forms in two ways. Okay? We mentioned the water droplets. They're little, tiny, sometimes microscopic. and then they combine with others, and they get bigger and bigger, and finally they get big enough that the air can't hold them anymore, and they fall. Okay? That would be coalescence of water droplets. And then the second one, the big ones, are growth of ice crystals. And we'll see the illustration of this pretty soon, hopefully today. They're carried up and form bigger and bigger ice crystals. When they get heavy, they come down, but if there's enough updraft, they get picked up and carried back up, and they can grow and grow. And if they grow so big in these supercell storms, they fall and don't get to melt on the way down. That's when it's hail. So a lot of those big drops were originally ice crystals. Big. Yeah, exactly. They were hailstones up there that didn't, that melted on the way down, and that made the big drops of rain. So that's the two ways. This will happen any time of the year. This mostly happens in the, both of them happen any time of the year, but when that forms the big drops of rain, this would be usually in warmer temperatures. Okay, because it melted those ice crystals. Okay, the coalescence process, that's this one. It takes place in warm cumulus clouds near the tropic ocean. Okay, so I said that can take place anywhere, but it's mostly in the warm. It's too warm for even to form ice crystals. Okay, so when I got my commission after graduating at Georgia Tech, and I was commissioned in the Navy, and my first set of orders were a ship coming back from the Western Pacific deployment. So it was in the Philippines at the time, but they were afraid by the time I got over there, the ship would have left. So they flew me to Guam, which was the next port of call for the ship on its way back. So I got there to Guam several days ahead of the ship. Well, I was just out of college. I hadn't probably received my first paycheck yet, so I didn't have really lots of money, and they put me in a barracks or BOQ or something up on the top of the mountain in the thing, not in the middle of a base or anything, and I had nothing to do, nowhere to go. I could only walk. I could call a taxi, but I couldn't afford that too frequently. So I decided when I got stir crazy inside, I said, well, I'm just going to walk around the island and see what's here. So I found out that if I left in the morning, I could walk maybe for about half hour, 45 minutes, an hour, and then I was going to get hit by a rainstorm. Right. And by the time I see it coming, I start heading back, it drenched me. By the time I got back, I was already dry again. Okay, and then so I said I'll do it. Say again? Well, I was just walking to kill time. So in the afternoon, I tried it in the afternoon. I get hit by rain. I found out if it didn't rain once a day on Guam, it rained twice a day. Okay, because it seemed like it rained just about every day, and you could never tell it was coming. That's what's happening. Warm cumulus clouds in the tropics, and just finally it gets so much moisture it falls out. And you can't really predict it very well. Now, quite often those clouds contain, they say, giant salt condensation nuclei. Fairly big crystals of salt. And salt attracts moisture, and that forms a condensation nuclei. Sometimes it's dust particles, sometimes it's other things. But especially if you're near an ocean, and there's been a lot of winds and stuff like this, and the salt water gets up into the air, well, salt crystals get in the air too. So that forms, if there's enough salt crystals there, they can form the condensation nuclei. Now the ice crystal process, that's here where we live, not in the tropics. This is in the middle latitudes where we live. And what happens, the ice crystals capture nearby water molecules and they grow as they're being uplifted in these big cumulus clouds. And finally, they get so heavy they start falling. Okay? But if they get updrafted again and again, they grow bigger and bigger until finally they're so heavy they can't help it. And if it's a supercell storm, hailstorm. But most of the time, they melt before they get down, and those form the big old water drop. Okay? So the ice crystals capture. Now, if it's wintertime and it's cold enough throughout the atmosphere, that continues to snow and it just falls as snow. But if it's summertime, then it turns to rain on its trip, on its travel down back into the warmer environment. And that's what makes those big old drops of rain. Okay. What was ice crystals melting on the way down, falling as big raindrops. Okay, everybody? Yes?
I'm not quite finished yet.
Okay, yeah. Take your time. So, those soft little summer showers with the misty type stuff, that's, it could have been ice crystal, probably not. It's more like the coalescence process. That's not over the tropics, but it can happen here. You just get so much moisture in the air and the water falls out. Okay? Usually those aren't heavy rains. Usually they are not associated with thunderstorms. They're just those misty kind of rains I love that kind of rain because most of that soaks into the soil. That's what I want it to be. You don't have much erosion with it. You don't have water running down, and carrying off good old topsoil. That's a great kind of rain. I don't like to lose my topsoil. Okay. We have little enough of it as it is. Man, when you have those big old drops falling, you have detachment and runoff. Not good. Detachment and transport. This is a pretty wordy slide here. Okay. And if you want to know what cumulus clouds are, go back to the previous chapter, chapter 22, and that'll tell you all about the different cloud types. It's really fascinating. Okay. So, what are our weather producers? Okay. This is bottom of page 577 on to the next page. Well, we have an idealized model. This doesn't always work, but it is sort of. Let me go get our handy dandy.
Oh, do we have time for it?
Wait a minute. Yeah, we are almost out of time. How could it be? Okay. So we'll begin next time with 23.2. That's really a pretty good place to stop. But I've lost my pen. Oh, there it is. Okay. Weather producers. Okay. Okay. All right. So we'll pause there. And what I will do is stop. Let's see. I think I will. Okay. Sorry about that, you two. So your third part, and this will be, you need 8 set of pages, and they'll always be in a pair. Okay. All right, and you have the whole back part of the page that you can write this on. Because I would say let's write your Devil's Tower questions on the answers on this side. Answer these questions, they give you plenty of room there. And on the back side, do your 8 page pairs. Okay. Why is this not moving? Okay, it's coming into play. Cece, you might need to turn off the front light again. No, the other one. Okay. And so do page number. Oh, let me get my pen darkened. Okay. Page numbers. And it's always going to be 2. Like, what did I say before? 30, 31. Don't use that one because I already did that one. Okay.
Summit means top, correct?
Huh?
Summit and top is the same. Summit, the word.
Yeah, top. Yeah, right. Okay. So page numbers. the lines close together. And what you list here is a feature. Okay. And what does it mean? Okay. And lines far apart. These are topographic lines. Okay, some feature. A road, a town, whatever. Okay. I can't spell. Okay. And then what does that mean? Okay. And by the way, those are all going to mean the same thing no matter what pages you're on, but I want to get it into your brain. That's what those mean. Okay. Any questions? And y'all can work together. Yes. You can't read my writing. Okay.
Yeah, I can't tell what the.
Okay. Page numbers. I'll do it back into the 3031. Okay. Lines close together. What's the feature? I think I said Double Oak Mountain, didn't I? Because there the lines are real close together. That's the feature. What does it mean? Anthony said very steep. And mountains are steep, right? That makes sense. And then lines far apart. What's the feature? It was Crocker something road, wasn't it? Crocker Mine Road. That's near where the lines are far apart. What does that mean? Someone else answered very flat. Okay? So, then you go, I did that one, you don't use that one. You go to any other two page numbers, 24, 25, 36, 37, whatever, and find places where the lines are close together, some feature, what does that mean? Lines far apart, and what does that mean? Okay? And y'all can work in groups, together. Whose is this? Was this one I was using? All right. You can go and turn the light back on if you want to. You want me to leave this up, or do y'all have this what you need? And do,
Yeah, look it up.
do 8 set of pages. Yeah, do 8 set of pages, and there's bunches of pages there, like 30, 31, 32, 33, 24, 25. Yeah. Pick out 8 pairs of pages, but not 30, 31. I just did that. Okay? And then do a feature, what does it mean? Then go to a new page. And do 8 of those and find one feature each for close together, far apart lines. Okay? Now, I would suggest that somebody get started on this. You can come back and do the other part later when someone else is using this. So I would say some of you start using the book, because otherwise the whole class is going to be wanting the book at the same time. So I'd say a third of you do your questions, the 5 questions. A third of you do Devil's Tower, and a third of you do the topographic map. Now, do some of you want to go down to a computer lab and use the computers there? If you do, 1:55, I talked with the instructor in there. He said it's perfectly fine. The class doesn't start there until 4:45. So if you want to use room 155, go now before 4:45. If you want to use for your Devil's Tower. But if you, okay. And if you have any questions, I'm right here. Okay? Do all of you have this yet, or you want me to leave it up? What? Which part are you doing? Answering the 5 questions, the Devil's Tower, or the...
I just answered the 5 questions, except for the contour part. I can't find that anywhere.
Okay, what is that?
The very last page, there's a question about Devil's Tower contour.
Okay, now that you go to either your laptop, your telephone, or you go downstairs to the computer lab.
Okay. Okay. Can you define, because I've read this like 3 times.
Right.
Can you define a contour line for me? Like, can you define that for me so I can understand?
Okay.
because I understand. So it just
You're going downstairs? Yeah. Room 155. Okay?
So it illustrates like hills and mountains. So these lines.
Those are your contour lines.
So what does that mean? Like,
Okay.
what is it showing?
All right. This shows that all along this line, you're 100 feet above sea level.
Okay.
Everywhere there.
So
Okay?
that would be
Here
like a
you're-
mountain that's.
Yeah, that would be around the edge of a mountain, say. This mountain right here, probably. You're going around this mountain at 100 feet elevation. Here's 120, 140, 160, 180, 200 is here. And 250 is right, or 260 is right there. Looks like 280 would be there, so the top of that mountain is between 280 and 300.
Okay. So contour line is above sea level.
Right. A topographic map shows elevation differences of your contour lines, okay? Now let's get contour lines on the bottom diagram, okay, and they're spaced at 20 feet intervals, and that's what we said. Those are areas of equal elevation. They're also called isoclines, equal elevation.
So
But they got a trail.
I don't. The relationship of the closeness of contour lines and the steepness of slopes.
Okay. So if this contour lines, it's 120, and the next one's 140, the next 150, and 60, and they're really close together, guess what? You're going up pretty quickly. If this one's 120 and that one's 140 and that one's 160, it's a very gradual slope.
Like this one. This one's not. This one's kind of gradual, right?
Yeah, right in here it's very gradual. Up here it's getting steeper and steeper because they're closer and closer together. This is really steep over here.
Oh, okay.
Okay.
I understand. Thank you.
Is it fair to say that you cannot just hike it? You have to use equipment to rock climb. That's what I found.
I wouldn't be at all surprised. When I've seen pictures of it, I sure don't want to hike that thing.
Legitimately just go hike it with your book bag. No, not like a bottle of water. You need to use equipment. So I didn't listen to you. I'm sorry.
What's that?
I didn't listen to you. I'm sorry.
Okay.
But about everything. But I know it. I'm terrible.
And Stanford had everything.
Okay, so
You know what? I'm just saying, we had the biggest archives on everything.
we doing this or
Huh?
not?
You're doing these questions here. 1, 2, 3, 4, 5. Now this one, wait till the end to do. Okay.
Okay.
Yeah.
And then
Okay.
those 5.
The other 4 you get from the reading of the first 2 pages. Okay. And if you have any questions, see. This is on Devil's Tower. You've already done that.
Yes.
Okay. And the next one you can get the book that and you can get work with her.
To find.
Huh?
What am I looking for?
Yeah, you're going pages. Okay, you're doing this. Get a set of a pair of pages.
Okay.
You open up 2930 or whatever it is. Okay. Find some place where the contour lines are close together. Find the feature that is in there. I did one on 3031, and that was Double Oak Mountain. There's many others, but that's one. What does it mean? Those contour lines are really close together. It means you're going up very quickly. It means you got a steep slope, right?
Okay.
Okay. So Double Oak Mountain would be that. I mean, it's a mountain. Okay, lines far apart. You have a line here, and then some there, big open area here. I mean, those are pretty flat. You don't have a 20-foot elevation change anywhere in that, so that's pretty flat. But find the feature there. I found Crocker Mine Road or something like that. Okay, that's the feature. What does it mean? Flat area.
Okay.
And you're going to do that for every one. Find the feature and they.
How many of them do we have to do? One?
8.
8?
8 pair of pages. And find one feature close together and one far apart on each page. If you happen to get a page with no close features, close lines, go further north because down south it's pretty flat, So. And you can go to the back of the book and find that. I was going blank when we said that.
What would you define on a contour map? Just the land in between?
Yeah.
You just call that land?
Yeah,
Not
but-
identified as anything? Like
Yeah.
the spaces filled in between?
The proper equipment.
Okay, yeah. Okay. Is this one of the questions? Or
Well,
okay, right, okay.
How would a nearly vertical cliff be represented on a contour map? So you're saying it would be represented by a single contour line surrounded by a vast space of just land?
No, if it's a vertical cliff, you're changing. I mean, the contour lines are almost on top of each other. So they would be extraordinarily close. In fact,
So if it's
they may
a
almost
cliff-
look like solid, you know?
Okay.
Yeah. Huh? Yeah, you got it.
Is it too steep? We said no.
Okay. Does everybody have this now, or do you want me to leave it up a little bit longer? Huh? Does everybody have this now, or do you want me to leave it up a little longer?
No, we don't have it.
Okay, well, I'll leave it up. Cece, could you turn on the light again? I was just going to say, y'all can read better if the light's on.
Right. So, yes, it is.
Oh, okay, yeah, it is. Okay, sorry.
Don't mind me, I'm okay.
Alright, yes. Change number 5, yes.
Well, the answer is yes. Yeah.
Yeah.
But it is too steep.
It is.
No, you cannot hike.
No,
Yeah.
yeah.
Okay, yes.
Alright.
That's true. We did, I guess, say
Yeah,
that.
we did. They always be up.
Okay, I'm going to put this on pause so you don't have to listen to me cough.